Hey YouTube, welcome to the second video of the Telegram bot story. Today, with plain old good whiteboard, I'm going to share some details about Telegram bots, how they are working, how we suppose as developers to interact with them. So you're welcome to join me and probably learn some new stuff. First thing first, Telegram is a messenger, but what's important is that obviously, as most of tools or software working over the internet, it has a client-server architecture. So basically there are clients all around the world, and there are some centralized servers that handle some pieces of information and help different clients or different users to exchange with the information. There is obviously a server, so it's a machine, it's a computer, usually powerful computer connected to the internet, and some sort of software is running there, a specific software called server software that is configured the way it can accept connections from the internet. The second part of the application are obviously clients. Let's add it to the schema. Let's have 3 clients for now. Okay, so let's imagine that we're back to Telegram and there is a client 1 sending some message, and this message has some metadata that tells us that to client 2, and the client 2 is actually connected, it's logged in, and client application is somehow handling the updates from the server. So either pulling, like asking, hey server, do you got anything for me? Give me that message. Or server, in more advanced protocols, server can actually push these messages toward the client and say, hey, there is a message for you, client 2, there is a message. Somewhere here there is a bot server. Yeah, it's actually a server as well. It waits for some incoming messages and it is ready to reply with some other messages. So how it happens actually? So let's imagine client 1 sends another message saying that it is supposed to be delivered to bot 1. Bot 1 is just a name for our server. Then the Telegram server, it's a Telegram server. The Telegram server, once received that, actually has this bot registered as well as a client actually, and it can send this message. Let it be command. So send this command to the bot server, and our bot server receives it as HTTP request. It has some fields, so it's actually a message which is of type, let's say, command, does something, prepare a reply, and sends it back to the server with HTTP request as well. So to sum things up, let's have a quick recap. So there are clients which can be mobile clients, these can be desktop clients, web clients, whatever. There is a server that organizes exchange, that is who is responsible for the exchange of all these messages. And there is a bot server sitting somewhere else, that is who is registered to Telegram server in a specific way and then interacts with it over HTTP request and responses, obviously. So the trick with Telegram is that actually on the Telegram server side there is a Telegram server plus something that is called MTProto server, and it is handling the specific MTProto It's a transport protocol invented and implemented by Telegram team. That makes a big difference. In order for this to work, as I mentioned, here is MTProto server, and I mentioned that bots are actually speaking using HTTP. We are having an HTTP server. So bots are speaking to HTTP servers, clients, it speaks to MTProto directly. Right now we don't care what about MTProto, etc. We're just using a HTTP protocol to reach it. It's important to know or remember that we have actually two ways of getting messages from the bots. So first way is to have a so-called long pole requests. So actually bot fires a request, HTTP request obviously, which is dangling there, let's say, until first activity occurs. For example, we have set it to 60 seconds, or we actually got a message. So whatever happens first, this request will be this request will actually trigger Telegram server to generate response, and response will be returned to the bot. This is a very convenient for having very simple bots, probably the ones that you are using on your own only. This is very convenient for development when you don't need to set up a complex infrastructure, you don't need a public endpoints. You can just run a bot on your local machine. As soon as you have connection to the internet, your bot is able to connect to Telegram server. You're happy, you're done, it's working. The downside of this is that it has its limitations. So just imagine that you are getting, let's say, 10 messages per second to send the request and to receive the response 10 times in 1 second. It's barely possible. So your bot actually will start lagging. Messages will be delayed. It won't happen on time. The second way to interact is actually for bot to have a known HTTP server, and this HTTP server must be available on the internet. Let's say mybot.com, right? And then we use a special command in Telegram, in bot father. This is a bot that helps us to manage the all our bots in the Telegram. So the bot father, we say that, hey, register a webhook, which is mybot.com for my specific bot one. So this way, each time Telegram has something for our bot, so basically a message or command, it fires a request to our public endpoint. It goes all over here to our bot, and our bot generates a response, and it is sent to the Telegram server. Obviously, here it should be okay. And then when we want something to be sent, we fire a request. With this approach, where our bot has own HTTP server, the one that is capable to handle updates from the Telegram server, we are able to scale much better than in this case when we use long pole. The downside of this is that we actually have to set up this HTTP server first of all. we need somehow to proxy it to our bots or built in the bot, so it's actually about internal organization of the logic. Thank you for watching this. See you in the next videos. Bye bye.